Hi all. Let's look at a rational function and how can we use the first derivative test to uh, guess the curve of a rational function. So we're gonna draw a sketch the curve here as well. Before we begin with the sketching, we need to find certain things. The first thing you find always would be the first derivative of the given function, right? And make sure that it contains uh, make sure that it contains any vertical asymptotes. By vertical asymptotes, I mean, are there any x values for which the function will have a division by 0? Now, if you look at this here, we have a difference here, right? Difference here and x squared terms here. So, this can be equal to 0 whenever x is equal to 4 and x is equal to minus 4, right? So usually this data is given in the question, but if it is not given, then you have to find it. It's very easy to find. Okay. Right, next we'll find dy by dx. This is what we need, the first derivative. So we have to use the quotient rule here. Quotient rule, x squared minus 16 into derivative of the function in the numerator. This is just 1. Then numerator into derivative of the denominator, x squared minus 16, derivative of the denominator. Then divide this whole thing by denominator squared, right? Denominator squared. So then what we have here, so the derivative of a constant is 0, so this term goes off, and here we get, so minus is there, the derivative of this one is just 2x, right? So divide by x squared minus 16 whole thing squared. So this is our dy by dx. Now we know that dy by dx is this. Here you can see that x cannot be equal to 4 or minus 4 is still there, the restriction is there, but you have only one x term in the denominator, which means there's only one factor, which means there will be only one turning point, right? So let's put this here, right? Let's put the critical values on the x axis here. So what are the critical inputs? Where dy by dx is 0, dy by dx can be 0 when x is equal to 0. So put x equals 0 there. And we have two other critical values where x is not equal to 4 and x is not equal to minus 4. We should also put that on the number line. So minus 4 and plus 4. You know that minus 4 and plus 4 is not included, so we put a whole circle there, a hollow circle, and here 0 is included, so we put a solid circle there, solid dot. Right, now we have to find the sign changes here. So find it on your own, and I will put the summary on the board. Right, so you can see here that we have minus 2, the coefficient is negative 2. So we should also keep that in mind. So what I'm going to do is that I'm going to assume that we have two factors here and make sure this factor is negative. So I put negative here in all cases. Then I count the sign of x in this factor, right? So when x is, when we are less than 0, that means x should be negative. So I put negative here. When x is greater than 0, x is positive, so I put positive. That gives me positive, negative. So positive means what is the shape of the function? So shape of the function is shape of dy by dx. Shape of dy by dx is positive means should look like this, and here should look like this. So you can see here that I draw a line here, right? I draw a line here, vertical line, to indicate that these two are vertical asymptotes, right? So if we have these, then it will be easier for you when you are sketching the graph. Okay? These two are vertical asymptotes, and this is one of our turning point because dy by dx is 0 at this point. So I just put a broken line there. You don't have to put a continuous line there, right? So this is a vertical asymptotes. Okay. Here what we have at x equals 0, then you know that your dy by dx is positive, 0, so it should be like this. Okay, then on this side it is positive, so a line like this. On this side it is negative, some line like this. Okay, then here the function is negative still, so on the left hand side of this vertical line it should be negative like this, and should be again negative like this. So you can see here that this line move closer to this vertical line here, and this line move away from the vertical line. So let's draw the shape of the function. What does it mean by the shape of the function? You can see, if sign of the derivative is positive, what does that mean? That means the function is increasing, right? Function can increase in two different ways, like this or like this. Now what happens here, that if you draw this curve here, what will happen is that this curve will move and cut this vertical line. So it would be as if it is cutting this vertical line. So we can't have that. Whenever we have vertical asymptotes, that means the function will approach it and touch the line. It doesn't actually touch the line, it will just approach the line and move towards infinity, right? So we cannot have that. It will not move towards infinity like that, but in this way you can see it goes upward, right? So the best option is to have this. So we will make the distinction of these two when we learn about the second derivative. Up until then we need to stick with the first derivative test, right? So you can see, when you have this type of derivatives, right, the line segment, you can have these two options. Out of these two options, this would be the most appropriate one, because in this case this will move up and it will eventually move towards the positive infinity. So our shape of the function would be like this. Okay. Now what happens in this case is still positive. That means the function is increasing. Now it is moving away from the vertical asymptotes, moving away. If we have this option on this side, then what will happen? It seems like the function, the vertical line has been crossed off by this function. So we cannot have this option here. Instead we have this one, because you can see here, this part looks like as if it's moved towards the negative infinity, right? So a line can be, a shape of the function would be like this in this case, as if it's coming from the positive, negative infinity. But you can see that the function is still increasing. In this point, I don't really need to find the, I don't really need to show you how the shape of the curve looks like here, because you know this already. This is a maxima. In here, again, you can see, if you sketch out the shape of the curve, right? So the function decreases in this region, function decreases and approaches these vertical asymptotes. So when it approaches the vertical asymptotes, function must decrease. What does that mean? It should go to negative infinity. So function can decrease in these two ways, like this or like this. If you select this one, you can see that the function will eventually go and hit the vertical asymptotes. But if you select this option, it will move and get closer and closer to vertical asymptote as it moves towards the positive, negative infinity. So the best option being like this. Again, the function is decreases in this range. If we have this to be the shape, and then the other shape would be, the shape of the function beyond this point would be like this. Right, like this. So we will discuss these in details when we come in the discussion, the usual discussion. So this should be the shape of the functions. Okay. So we have to find the the maximum point of this function as well. So make sure to represent all of these in your answer sheet. And we also have a table. You know how to write down the table, so I'm not gonna go through that. And this is all we need for now to sketch the curve. Then after that we also need the horizontal asymptotes and also the intercept, y-intercept of this curve. Okay, we'll show that later. Right, so I found the maximum point as well, and also I found the horizontal asymptotes. You know how to find them. As x tends to positive or negative infinity, we have to check what the value of the function is, right? So what the function is approaching. So if I do this simple thing here, I taken out x squared, then I get 1 minus 16 over x squared. As x tends to positive or negative infinity, we have x squared here, so it doesn't matter what the sign is. This part will be 0. And also here we are left with 1. Okay. Then our function would be 1 over x squared type. So 1 over x squared means a power of x is in the denominator, which means as x is increasing, the function will die down up to 0. So when x is at negative infinity, when it is approaching negative infinity, function will approach 0 in this case. So our horizontal asymptote is 0. Now let's sketch out the curve of this function. So first of all, draw the vertical asymptotes. As you can see, this is not to scale because I don't have enough space here. So at x equal 4, one vertical asymptote, at x equal minus 4, another vertical asymptote. First, make sure you sketch out the vertical asymptotes. Then you have to sketch out the horizontal asymptotes. So what is our horizontal asymptote? The horizontal asymptote is y equals 0. Y equals 0 is actually the x-axis, right? Because on the x-axis our y coordinate is 0. So it is already there. So we will have to sketch horizontal asymptote in this case. Next, locate the maxima or minima. Locate the turning point. Here we have only a maxima. So maxima occurs at 0, minus 116. So this actually occurs on the y-axis. So here minus 1 over 16. This would be our turning point. You know that whenever you find the turning point, you have to do this, right? Since it is a maximum, I just do a small sketch of a maxima, right? Shape of a maxima. Yeah. Then what happens? You can see our shape would be like this. Okay. So as x increases, function will decrease in this region. Derivative and negative, it will decrease, and it will approach the vertical asymptote. So it should move like this. Never touch vertical asymptote. In this region also, you can see goes like this. So this should be symmetric. Right? It should be symmetric. Then what happens? If we move away from this region, we have a function like this. And the function comes from the positive infinity. It comes from positive infinity because the function is decreasing. Function is decreasing, it comes from positive infinity. You can see it is directed upward, right? So which means your function comes from here and goes like this. And what happens here is that the horizontal asymptotes, it will not decrease. It will not decrease indefinitely. It decreases up to this axis, right? And it will approach this axis and it will be an asymptote in this case. So we have this function decreasing, y equals 0 up until y equals 0, and it would slowly approach y equals 0. So you cannot cut this x-axis. On this side, it's the same thing. You can see the function will approach the vertical asymptotes as it moves towards positive infinity. Right? Will be increasing, and the horizontal asymptote is y equals 0. So it goes like this. Okay, right. So this is the shape of the curve of the given rational function. So we will do more examples on this during the class, so that it will be to you, especially with the horizontal asymptotes. So horizontal asymptotes are there to show you that the behavior of the function as x increases. So as x increases, the function should approach y equals 0. Why it does not cross here? If it crosses here, suppose now, if it crosses here, crosses the x-axis, so one could argue the function is decreasing, so it can decrease indefinitely, right? So what happens is that if it it decreases indefinitely, as x tends to infinity, y should be negative infinity, but it says y is 0. That means it doesn't decreases indefinitely. As x increases, the function of the value of the function must approach the x-axis. Suppose it goes below this x-axis, then to approach the x-axis as x tends to 0, it has to take a turn, right? If it takes a turn, what does that mean? We also have a turning point here, but according to our first test, we have only one turning point. We cannot have this kind of shape. So our function must be like this. Should look like this. So these are called vertical asymptotes. Here the vertical asymptotes, x equal 4 and x equal minus 4, the vertical asymptotes. Right. So we'll look into more examples during the discussion. Thank you.